sounded so aggressive there.
You were very excited because you remembered all of a sudden. I'm not going to go back and show the previous one, though, because, well, I don't know, our total of 10 viewers will just have to put up with that small omission. But...
Wait, 10 viewers?
What'd you say?
10 viewers, question mark?
We have a very small number of viewers on these videos when I upload them. There's like between 5 and 12 people, I think, on all of these videos, so it's not very many.
That's more than one.
It is more than one. I think the Matrices ones had more. They might have like 20 or something, but they're very long is the problem. People don't watch long videos. But good, so this limit clearly doesn't exist, because this 2 over h is a problem. As h goes to 0, 2 over h is going to blow up to infinity. So this, I mean, I don't know why I put an equal sign. I should put dne for does not exist. So that's the problem. Exactly as you say, the true value, quote-unquote, which would make this limit exist, would be putting in not 2 minus 2, well, not for this thing, it would be putting in 4 rather than 2. So, indeed, 1 is false, and only 2 is a true statement. Okay, other thoughts on this?
I had no other thought.
Good. I apologize for these standardized test questions, but I think it's good for just quick, crunchy, blitzy things. Okay, so this is another 1, 2, or 3. So we're going to decide which of these statements are true for every function f. So we have to decide if these are generically true. Every function f which has the property that the limit as x goes to 0 of f of x over x exists. Let's see, this limit exists and it's a real number L. So we can assume this limit exists and it's equal to L. We can also assume f of 0 equals 0. And if those two things are true, if this limit exists and f of 0 is 0, is it true that f is differentiable at 0? Is it true that the value of the limit, the value that this limit approaches, must be 0? And is it true that the limit as x goes to 0 of f of x equals 0? Notice that this is really, since f of 0 equals 0, option 3, or statement 3, is really the statement that f is continuous at 0. Right? That's another way of saying continuity, because we're saying the limit as x goes to 0 of f is the same as the function value. So, okay, what do you think? Which, if any, of these are true?
So we can automatically A and B.
We can rule out A and B. Okay, why can we rule out A and B?
I believe that we can rule out B since we know that 3 is true, and rule out A because we know that 3 is true.
How do you know that 3 is true, or in other words, how do you know f is continuous at 0?
Are you checking that I was paying attention?
No, I'm asking what the reason is, because when I wrote this down, I wasn't telling you that this is true. I'm saying that the statement 3 is equivalent to the statement that f is continuous at 0. We still have to decide whether f is continuous at 0. I just told you that 3 can be reworded this way, right?
I don't see how that doesn't show that 3 is true. I worded that terribly.
Okay, so the statement 3 is the statement that f is continuous at 0. So why is this true? What is the justification for this, is the question.
Because we see that the limit that we are interested in is equal to the calculated value of it.
How do we know this is true? I mean, we're not assuming statements 1, 2, and 3 all hold, right? We're deciding which of these hold. So if 3 is true, then indeed the limit equals the calculated value. But we're being asked to decide, is it true that the limit equals the calculated value, right?
Oh my god, I'm dumb.
I don't know. You're not allowed to say that. No one is dumb. So yeah, since the question is asking which of the following statements are true, so we have to decide, is it equal to the calculated value?
So, given the information that we have, would seem that so we do not know that this function is continuous or derivable.
Differentiable, but
Right. I don't know why I said that.
well, they could be true. I mean, all that we know. So just to emphasize, the things that we know are true. So we know the limit as x goes to 0 of f of x over x equals L. So this is one thing we know. We know f of 0 equals 0, and then the things we don't know are true, but we want to decide whether they are true are, well, one, f is differentiable at 0. I'm just rewriting the three things there. F is differentiable at 0, L equals 0, or f is continuous at 0, right? So my question to you is, well, let's look at this first statement. Is the statement, if we assume this is true, if we assume the limit as x goes to 0 of f of x over x equals L for some number L, does this statement let us decide whether any of these three things are true? Does this logically imply any of these three? Like these. I guess I should really ask, do these two taken together imply either of those?
I am inclined to believe that does imply the first statement.
It
But I do
implies
not.
this. Okay, so you think it implies f is differentiable, was the claim?
Yes.
Okay, let's see. Well, first, do you have an idea of why you suspect that's true? Well, let's write the definition first. So what does it mean for f to be differentiable at 0? What's the definition of this statement?
So, just by that, f is differentiable at 0 if the limit as h goes to 0 of x plus h minus f of x all over h equals some number.
In particular, when x equals 0, though, right? It's differentiable at 0. So,
Right.
so f. So I'll take the sentence you just said and put in 0 for
Okay.
x, right? So minus f of 0 over h. Yeah. So
I see what's going on here. How are you going to pull out dummy variables?
yeah. So this is just replace h by x. This is the same as limit as x goes to 0 of f of x minus, what's f of 0?
0.
Good. So this thing. Ah, but we know that exists. Good. Okay. So that must be true, because we assumed that limit exists and it's equal to L. Aha. Good, so as you say, you guessed that 1 should be true. Okay, so we know 1 is true. I claim we can immediately deduce something else if we know 1 is true. What else do we know?
I'm just going to get rid of A and C right now, just because.
Good.
So since that limit since that exists, what do you think? It would seem that if we simply... Oh wait, never mind. I almost said that if we insert 0 into x for our same true limit, I was going to say that must mean L is 0, but then I realized that's dividing by 0.
Yeah, so in fact we can come up with a counterexample pretty easily. If we want to decide whether 2 is true, why don't we just try to pick a function where the derivative exists at 0 and f of 0 equals 0, but the derivative itself is not equal to 0. And I claim there's a very easy function we could pick for that, which is this thing. Right?
Well,
Here's f. So why does this
beautiful.
why does this disprove 2? Well, this limit exists because clearly this guy has a derivative at 0. F of 0 equals 0? Yep. Is it true that L, which is the derivative at 0, equals 0? No, L equals 1. Right. Good. So 2 is false.
I totally forgot about the for every function f.
Yeah, have to be quite general. Okay, so now we just have to decide, is 3 true? Is it B or D? So do we know that the limit as x goes to 0 of f of x equals 0, or in other words, that f is continuous at 0?
Deep thinking. I think that, how do I word this? Wording things is hard.
It's a skill that takes a long time to craft precise sentences. I don't think I've mastered it.
Of course, assuming that f is continuous would be a roundabout, not roundabout, catch-22. I don't even know what I'm trying to say.
Yeah, we can't add stuff to the list of assumptions, right? We only know these 2 assumptions, and we have to decide, do those assumptions imply that it's continuous? Good. Fuck. There we go.
Profanity.
Profanity makes everything better. I claim there's a one-step argument. So, if we know f is differentiable at 0, must it be continuous at 0?
Yes.
Yes. Good. We proved this. Differentiable implies continuous. So, if it's continuous at 0, the limit as x goes to 0 of f of x must equal what you get by plugging in 0, which is 0. So, it's differentiable, it is continuous, therefore D. Okay.
How much work did I actually do there?
I think you did most of it. I was just, I don't know, asking leading questions. Okay, other thoughts on this?
Buttons. I have no further thoughts.
Okay. How confident are you, I mean, if you were taking a test with questions like this, after this discussion, if you were given a similar question, maybe not exactly the same, but testing, the same concepts, differentiability and continuity, how confident are you that you could correctly figure this out within like 2 to 3 minutes? Like a percentage, perhaps, the probability that you would figure it out.
I probably first time around because I'm would have been overconfident. I don't solved it right.
Ah, okay. So you think
Seen it, I'm slower and probably have like 75% chance.
okay. Alright, yeah, that's not bad. Yeah, let's keep moving then. So, this is, I mean, maybe after finishing CD3, the percentage will go up a little bit, so, but I'm happy with that. If you are 75% likely to get it right, I think that's adequate. Okay, good, another one. So, now we're given a function f. It's defined, note, it's only defined for positive x values, so we can only plug in positive numbers to this function. It's defined by the square root of x raised to the x power. Okay, so this is our definition, and now we're asked which of the following statements is false. So notice that this is useful for kind of metagame thinking here. If only one of these statements is false, that means that the other 4 of them must be true. So if we can use this to kind of deduce certain things that could be useful in figuring out which one is false once we decide which ones are true. But anyway, we'll see that in a moment. So, which of these is false? 1, that the limit as x goes to 0 from above. Notice we have to take the limit above because it's only defined for positive inputs. The limit as x goes to 0 from above of f of x equals 1. Second, the limit as x goes to infinity of f equals infinity. I don't know if we've discussed this symbol, but when you say a limit equals infinity, this is kind of an abusive notation. When you say a limit equals infinity, what this really means is that the limit does not exist, and that you can make f of x arbitrarily large by making x arbitrarily large. So you can write that with epsilon, or you can write that in a formal definition if you want. So, for any n greater than 0, there is, I don't know, a y greater than 0, so that f of x greater than n when x greater than y. That's the formal definition of saying a limit equals infinity, but this is really a preview because we'll talk about this more in chapter 6, I think. So anyway, hopefully that makes sense. This statement just says that the function gets larger and larger as its input gets larger and larger. Good. So is that true? Is it true that f of x is the same as x raised to the power x over 2 for all positive inputs? Is it true that
Yes.
Yeah, okay, so that's good. We know that's true just by power to a power, right? So good. This is true.
Your resolution keeps getting worse, and I don't know why.
Oh no, it's probably damn it, it's probably my Wi-Fi. No, it's green now, so it says green. So in principle, the resolution should not get worse, but I guess it is. Okay, so the last two, is the derivative positive? Is the derivative increasing? Notice that if the derivative is increasing, that means the tangent line slope to the derivative is positive. So this is the same as saying the second derivative is positive. So anyway, alright, lots of things. But what do you think we should do to figure out which of these is false?
I also believe that D and E are true.
Why are these true?
I believe we have gone over in the past about exponential functions and thinking. I don't know if what we did about exponential functions applies here really.
What is an exponential function? An exponential function means
Something to the power of x, I believe.
it means a constant to the power x. 8 to the x.
And this isn't a constant.
No, this is x to the x. So this is a little trickier, right? So maybe to check D and E, it would be useful to just start by actually computing the derivative, right? Why don't we just compute f prime and see what it is? So I claim that we've seen a way to do this. What is the trick? We can't use any of the standard rules. The power rule doesn't apply here because the base is not a constant. The base depends on x, and so does the exponent. So what trick do we have to use to get the derivative of this function f?
You take the log of both sides.
Good. So on the left, log f. On the right, I'll just use this because you told me this is true. This is the same as x over 2 log x. Why? Because I just took the log of the right side and then used the log of a power, so I pulled down the x over 2. X over 2 now multiplies the whole log. And now I should differentiate both sides. What do I get when I differentiate both sides?
We're going to get, I believe, 1 over f equals...
Oh, careful, chain rule this guy. 1 over f times what?
Oh, right, because this isn't x. Never mind. Let's see, 1 over f times f prime.
Good. And on the right?
I believe we need to product rule this.
Mm-hmm.
So this is going to be... let's see. The derivative of x over 2 is going to be 1/2, I believe?
Good.
Sounds right, yeah. Times log x. Plus 1/2 times 1 over log x. Just trying to think if there's a better way to do it.
Well, hold on. It should be x over 2 times the derivative of log x. What's the derivative of log x?
Alright, I keep chain rule. Derivative of log x is going to be 1 over x times 1.
Yeah. Well,
Right.
yeah, we don't need the chain rule, but it's it's x over 2 times 1 over x. Maybe you said by accident 1 over log x. I think you meant 1 over x, but good. Okay, so this is a half log x plus 1/2. Okay, good. So that is equal to f prime divided by f, right? So that means that f prime of x, if I multiply both sides of the far left and the far right by f, that means f prime of x is f of x times this whole quantity, which you've just told me on the right side, a half log x plus a half, and then I'm just going to plug back in this expression for f of x, this, I guess, x to the power x over 2. So it's x to the power x over 2 times 1/2 log x plus 1/2. Okay. I think this is right. Okay, so what do we know about this derivative? What is this? Does this help us in deciding whether D and E are true?
I think that your screen froze.
Oh no. That's no good.
Oh wait, things are moving again.
Okay, good. I don't know why my resolution keeps dropping, but okay.
So what was the question again?
Right, so does this help us decide whether D and E are true? Whether the derivative is always positive and whether it's always increasing?
I believe that for x below a certain value, I assume this is log base e.
Yes, whenever I write log, it's always log base E. That's my religion.
Okay. So I'm inclined to believe that for x, this may be negative value in the bracketed quantity.
Yeah, why don't I let x equal e to the negative 1 million power? This is a positive number, because e raised to any number is going to be positive. So this is a positive number, which means we're allowed to plug it in as an input. And as you say, when I put this into the bracketed quantity, I get a half times minus a million, so minus 500,000, plus 1/2. So a huge negative number multiplied by, some positive quantity. So a huge negative number multiplied by something positive is indeed negative. So I think what you're getting at. So I think we have decided that choice D is false, which means that it is the correct answer for this question, because we are asked which one is false.
Beautiful.
Good, okay. So, a bit tricky, but this logarithmic differentiation thing is very powerful. So, other thoughts on this?
I have no other thoughts.
Onward then. Okay, so finding the equation of a tangent line. So, I think
I can't actually make out what's being written anymore.
Oh no. Is the resolution that bad?
I think so.
I will zoom in and also say it aloud in case that helps. But okay, so we're asked to find the equation of the tangent line. Actually, zooming in just made it really pixelated, so I'm not sure that helps at all. Maybe I'll zoom out and then write it larger. How about this? Y equals x plus e to the x at x equals 0. Okay, so we want to find the tangent line to this graph. I'm not going to try to graph it, but to find the tangent line, we certainly need the slope of the tangent line, and then we also have to figure out the intercept. So let's get the slope of the tangent line first. What should I do to find the slope of the tangent line to this plot at x equals 0?
I believe we are taking the derivative.
Good. What's that?
So since we can split this, we see that derivative of x is going to be equal to 1, and the derivative of e to the x is going to be e to the x.
Okay. So then when we evaluate at 0, what's the derivative at 0 of this thing?
1 plus 1.
Math. Okay.
Whoa!
Excellent. So it seems that that has already ruled out many options, because the slope has to be 2, right? So it's either 2x or 2x plus 1. So how do we figure out what the intercept of the tangent line should be if we know its slope, and we know that there's this point 0, well, if I plug in 0 here, I have, well, I'll ask you. So when I plug in 0 to this equation, x equals 0, what do I get for y?
You're going to get that y equals 0.
Well, you're going to get y equals 0 plus e to the power 0.
Oh, wait, 1.
Yeah, good. Okay, so 0, 1. Okay, so I think that basically nails it for us. So which of d and e should it be, given that this is a point on the line?
By the power of pre-algebra, it's e.
Good, yes. Pre-algebra and algebra 1 and geometry. High school math curriculum seems incredibly repetitive to me. It seems like you do the same thing for basically 4 years in a row, but maybe that's just me. Okay, other thoughts on tangent lines? This is pretty simple.
I have no other thoughts. But now that I think of it, I think I could have learned trigonometry in 8th grade.
Easily, yeah. I mean, many people I know, both former students and former classmates, studied trigonometry on their own as early as late elementary school, 6th grade. It's not unheard of.
I think I actually tried it once, and I was like doing fine at it. I just forgot about it by the time 9th grade came around.
Yeah, it's not uncommon. Oh, by the way, did you, I mean, since you're talking to your chem teacher, I was curious if you have had any contact with the pre-calc teacher or know what that covers.
I have not.
Okay. I'm curious to
English.
see. Because, like, your chem teacher seems very helpful. I was wondering if the pre-calc teacher is going to be helpful and if he or she would be willing to modify your curriculum as well. Because, I mean, if you show them your responses to, you know, consolidation document 1, where you've already, 1, derived Euler's identity, 2, understand the Lambert W function, etc., then they'll realize that you know more math than them. But, I don't know, maybe they're not the sort of person that would be willing to change your curriculum because of that.
That would be quite funny. First interaction with a pre-calc teacher is sending them the stuff you...
Yeah, I mean, it would certainly be convincing. It's just hard to do that in a way that doesn't make you sound like an arrogant prick. So, I don't know. Maybe that's too challenging.
You lead it by saying, I apologize for acting like an arrogant prick when I...
That's the best way to diffuse accusations that you're arrogant is to preface the statement by acknowledging or apologizing for being arrogant. Oh dear. Okay. Good.
Social skills.
Yeah, I don't have any of this. All right, this question. We're given a line, y equals 10x. So I think the derivative of this guy is fairly clear. And we're asked for what value of b is this line tangent to the curve y equals bx at some point in the xy plane. So for this line to be tangent to this curve means that there has to be a point 1 where the tangent line slope to this guy has to agree with the slope of this line, and 2, that there has to be a point where the actual point on this curve, y equals e to the bx, which of course looks like, you know, well, at 0 it's 1, and then it blows up like this, and then it does this. So there has to be a point where this curve actually touches this line and their slopes agree. So we're asked what value of b in the exponential would make those two statements true. One, that there's a point where the slopes agree, and also where the 2 points on this line and this curve agree. Okay, what do you think?
Resolution going wild. Let's see.
Look.
It went up to like 720p for a few seconds, and then it's back down to where I can't read whatever number is in the bottom right corner.
Damn it. I don't know why it does that, because I picked like 360p, like whatever would make the fastest. Yeah, now all my drawing is fucked up, but alright, I'll delete it. I don't know if that makes things better. Again, it is pixelated.
Did you say you chose 360p?
I thought I did. I don't know.
You should probably. I forget if. I'm pretty sure you could sacrifice the speed for clarity, I guess.
I guess I can. Okay, why don't I stop and then start again? No, it's on 720. Okay, never mind. I lie.
Huh.
The frame rate is 30 there.
That's weird. I don't know. You see, now it looks normal for the most part.
So I just need to...
Like Twitch.
What'd you say?
What were you saying?
I was saying, so I just need to restart it because now it looks normal. But what were you saying about Twitch?
I don't know what kind of laptop you have, but you might be able to Twitch stream and save it to YouTube afterwards.
I should try that. I mean, when we first started doing this, I tried using... There's like a streaming option down here. You see it says start streaming as opposed to recording? And remember when we started streaming, you said that it was so slow that it was like uninterpretable, right? Like, if I hit
Right.
if I hit streaming here, it gives me some options where I can put an IP where the streaming is supposed to get sent to, and you can put that for like Twitch or YouTube. So apparently, if I did Twitch streaming or YouTube streaming, it would just be unwatchable, which is kind of sad.
Oh yeah, your voice would also lag behind by like 10 seconds unless we were on Discord. I mean, the video would.
You probably don't want that.
Right. Anyways. Are you there?
I am.
Okay.
So what should we do for this value of b stuff?
I guess we can take the derivative of our function.
Okay, so this exponential guy. Good. So what's y prime?
Let's see. Prime is going to be the composition of functions with outer as e to the x and inner as bx. Let's see, that is going to be e to the power bx times b.
Yeah, derivative of the inside is b,
Okay.
so b e to the bx. Good. Okay, so that's the slope at any point. So we're trying to match up both the point on the line and the slope. So maybe it's useful to write down what the slope of this thing would be at a particular pair. So we'll write down both the point on this guy. So there's a point x comma y, so there's a point x e to the bx. So this is the point. And then, as you say, the slope is given by y prime at that point x, so it's b e to the bx. So that's every point on the curve and the slope at that point, the tangent line slope at that point. And we're comparing that, we're trying to find a value of b where that matches a point and slope on this line. So these are points x, 10 times x, and the slope, of course, of this line is always 10. Okay, so can we find a value of b? I don't know if, I mean, you can, one way to do it is to just look at these options and see if any of them work. Can we find a value of b where there's a point x comma e to the bx which matches x comma 10x, and where the slope b e to the bx also matches the slope 10? So in particular we need b e to the bx equals 10, so we need this to be equal to 10. And we need, maybe I'll just write, yeah, this is getting sloppy. I'll write this at the bottom. If we're going to match those two equations, we're matching both the slope and the point. So match, we need b e to the bx is the slope 10, and matching the 2 points, we need 10x equals e to the bx, right? Just matching the y coordinates of these 2 points. So can you see a value of b which will simultaneously satisfy both of those conditions? For some x.
So I'm thinking, could we set the, this is probably like a super long-winded way to do it, or it might not work at all, but could you take our right orange equation and divide by x and set them equal to each other?
Take this thing and divide both sides by x. Oh, to get 10. And then you say set 10 equal to the right side after dividing by x?
Yes.
Okay. Yeah, I think that works. So do this, you get 10 equals e to the bx over x, and b e to the bx equals 10. So I think that gives us b e to the bx equals e to the bx over x. Okay, so we need this thing, but then I think we can cancel e to the bx from both sides, so I'm not sure this gives us a lot of oh, maybe this, yeah, actually this is useful. Interesting. Okay, so I cancel e to the bx on the left and the right, and I find that x times b equals 1, or in other words, for these both to be satisfied, I need the point x to be the same as 1 over b. Okay, that's useful. So let's rewrite these two equations assuming x equals 1 over b. Good, so...
Jeez.
What'd you say?
I said Jesus, that worked.
Yeah, I mean, that was surprisingly useful. So, okay, so I put in x equals 1 over b, I think. Yeah, so that means this will be e to the 1, this will be e to the 1, this will be 10 over b, so we need b, that was sloppy, b e to the 1 equals 10, and we need 10 over b equals e to the 1, is this right? I don't know if I made a mistake yet. Something seems mysterious here. Did I do something wrong?
I don't really understand where the 10 over b equals e came from.
That was from this equation. So 10 times x, and you say x equals 1 over b. So 10 times 1 over b equals e to the bx, but b times x is supposed to be 1, you say.
Yes.
So this seems okay, I think, unless... Oh, I'm being sloppy. There's one problem. In solving this for x equals 1 over b, we've assumed x is not equal to 0, right? Because if x equals 0, the right side is undefined. So there's actually two solutions. Alright, I'm being sloppy, yeah. Either x equals 1 over b or x equals 0. Okay, so there's really two branches to consider. So we can either try to solve these two equations, or we can plug in x equals 0 and try to solve that result for b. So let's do both. Let's do the first one, where we put in x equals 1 over b, which I think gives me these two equations, as you say. And I think we can solve these two and get b equals 10 over e, which seems to work for both of them. If I multiply both sides by b and then divide by e, I get again b equals 10 over e. Right, but now I'm confused. B equals 1 over e isn't the answer that I thought this was supposed to be. Because I thought we were... Wait, do you see something I've done wrong?
You have the answer on hand.
I do. I'm told that the answer is d, e to the power 10. And I didn't think of this trick that you suggested of setting these equal. When I was solving it, I thought, well, let's look at some easy points. Let's consider, say, x equals 0, in which case this guy has slope... Or wait, did I do this? Yeah, so if we want this guy to have slope b at x equals 0... No, that's not right either. Okay. I'm told D is correct, and now I'm confused about why this is correct, because you've given me what I think is a convincing argument for why A should be correct. Um, okay, well, I'll ask you for help then. So what did I do? I apparently have done something wrong in this branch here that I was trying to solve for x in terms of b. Do you see a mistake that I have made?
Are we actually allowed to divide? Yeah, I keep saying my v is like an f. Are we actually allowed to divide each side by x on the right orange equation?
So divide both sides by x. I think if x is non-zero, we can do that, right? If x is non-zero, then this is just algebra. So that should be true, I think. Yeah, I think that should be true.
So I am questioning the implies xb equals 1.
Ah, so you say, can I cancel e to the bx on both sides?
Yeah.
To get b equals 1 over x.
Because you divide by ebx on each side?
That should still be allowed as well, because e to the power bx is definitely non-zero, so I should be able to divide both sides by e to the power bx. Right?
Okay.
I think that part seems true. What have I done?
I think you ended up with the equation by dividing each side e to the power bx. I ended up with the equation b equals 1 over x.
Yeah, so b equals 1 over x, and then I multiply both sides by x. Right, so x times b should be 1, I think, if that's true.
Okay. We could just... Would Wolfram take something along these lines?
About finding the tangent line, Wolfram would take the derivative of this guy. I don't know if he would find the value of b where they match. Man, now I'm confused. 10 over e, this option A is looking very, very convincing now that you've walked me through this argument. So, alright, well, let's do something else. So, let's plug in these two options, A and D, and see what point they are supposed to agree at. Let's do some sanity checking. So first I'll plug in b equals 10 over e. So we're comparing y equals 10x to y equals e to the 10 over e x, which has slope at any point x, as you've told me, 10 over e to the 10 over e x. Right, so now we just need to find where, at what value of x does this guy have slope 10. So we're trying to, slope 10. So we want this to be 10. So we're trying to find the point where the two tangent line slopes agree. So to find a value of x where this would be true, we would cancel 10 from both sides. And we would, I guess, use a power to a power perhaps. We would have e to the 10 over ex minus 1 equals 1, I think. Which means, we could take the log of both sides. Log of 1 is 0. So 10 over ex minus 1 is supposed to be 0. So that's fine. And then we would need x, well, we have 1 on the right side and multiply by e over 10. So x equals e over 10. So now let's ask, is this consistent? If I plug in x equals e over 10, indeed, I'm going to get a slope 10 here. Do the points on the line and the curve agree when x equals e over 10? Well, let's see. This guy, I'll do this up here, I guess. So the line, the point will be x, y, which is x, and y is 10x, so xe, and the curve will be x, y, well, again, x is e over 10, right? Wait, what am I doing? Plugging in x equals e over 10, so e over 10 e, and on the curve, e over 10, and then e to the power of e over 10, which is also e. Now I've confused myself. I think I'm convinced now A is the correct answer, and the answer key is wrong. This agrees with what you've just told me, and it seems totally consistent. Is there... Maybe I will check now to see if I've written down the... Do you see anything wrong with what I've done? Or what you've told me?
I don't think so.
Oh, this is very mysterious. Okay. Alright. This will be... Alright, 2005.
Now low enough res that I can't even tell what the answers are.
1997. Oh, wait. This is 23. 2005. 23. GRE Math. Does the question match? Aha! I wrote down the wrong one. Okay, that explains it. Excellent. I wrote down the wrong answer because I was looking at the wrong year of the exam. Alright, I apologize for this. It is indeed A. Man. I would like to pretend that I did that intentionally so that we could work through something as an exercise, but that was totally just me being dumb. Okay, I agree with you. It is indeed A. Cool. Alright, I apologize. That was a very poor use of your time, but anyway, comments on this?
Was it actually 4 years if it was amusing?
I don't know. I mean, if you're actually amused and not frustrated with me for screwing that up, then yes, I think that's a good justification. Okay, I will attempt to redeem myself. Okay, so now we are given a new function. So this guy is again defined piecewise. So when x is not equal to 0, this is x e to the power of minus x squared minus x to the power minus 2. So this is minus x squared minus 1 over x squared, in other words, in the exponential. Maybe I should zoom in if your resolution is still bad. But anyway, so we're asked at how many values of x does this guy have a horizontal tangent line. So again, horizontal tangent line means the tangent line's slope is 0. So what should we do to find how many places where this guy has a tangent line with slope 0?
So before that, I had to ask, why do we even need to get x equals 0 if when x equals 0, then the top one would be 0?
The top one would not be 0 because x to the power minus 2 is 1 over x squared. And we cannot plug in x equals 0 to 1 over x squared.
Oh, okay.
So the top guy is undefined at 0, right?
Ooh.
Good question, though. Yeah, it seems kind of strange to define it piecewise, but whenever you have a 1 over x, you have to be very careful and acknowledge that your expression is undefined when x equals 0. Good, okay. What should we do then?
I guess we should take the derivative of the top function somehow?
Yeah, let's try that. So if we take the derivative, as you say, we can only use the top function, and the derivative will only be true away from x equals 0. So we may have to be a little careful about the point x equals 0, but let's deal with that subtlety later. So just looking at the top equation, when x is not 0, away from 0, what's the derivative, using the product and chain rule, of this guy?
I believe that we first have to apply the product rule, and C is going to be e to the power negative x squared minus x to the power of negative 2. And that is added to x. C. The by the chain rule is going to be with an outer function e to the x. This is going to be e to the power of that junk. Let's see. Is there something that has to do with same base but different power? And does that apply here?
Well, I mean, we can just use linearity. If we're differentiating the inside function, you know how to differentiate x squared?
That's right.
Yeah, okay.
So it's going to be negative 2 minus, negative 2 plus.
Or negative 2x, right?
Right, yeah, negative 2x plus 2x?
2x power rule, so...
to the power of negative 3.
Good. Alright, so that's the derivative away from 0, which is good, because this guy is also undefined at 0. Okay, so that's the derivative away from 0. Let's try to find places where this guy has a horizontal tangent line away from x equals 0. So I'll put an equal sign with an exclamation point. We want to find places where this thing equals 0. So can we find places where that's true? Well, we can certainly divide both sides by exponential of this junk. Why can we do that? Well, the exponential of some number, some real number, is always going to be non-zero. In particular, it's positive. So we can always divide both sides by a positive number, assuming x is non-zero, so that this thing doesn't blow up. Ah, fucker. There we go. Alright, so that means if we divide both of these terms, well, both sides, and therefore both of these terms by each of the junk, 0 equals 1 plus x times minus 2x plus 2x to the minus 3. Okay. And it would be nice if we could clear away this x to the power minus 3. So, oh, were you going to say something?
How can we divide by e to the power of junk if we have... Oh, wait. We can do that. Never mind.
Yeah, it's important to understand that we can always do that if this argument of the exponential is defined. So if x is non-zero, this thing has to be positive, right?
I was about to say that something was up with the rightmost element, but then I realized that that is being multiplied by e to the power of junk.
Yeah, good. Yeah, so we could factor out, it would make it easier, I think, if we wrote e to the junk times 1 plus x times this thing. And then the fact that we could divide would make it clearer.
The more you know. Anyways.
Yeah. Okay, so I'm just gonna, well, this is bad board work, but I'll move down here. I want to get rid of this x to the minus 3. So I'm going to multiply everything through by x cubed. And that's going to give us a 0 is 1 times x cubed is, not x cubed, sorry. X times x to the power minus 3 is x to the power minus 2. So I really want to multiply through by x squared to get rid of that. Right, so in other words, if I distribute this x, the whole right side is now 1 minus 2x squared plus 2x to the minus 2. And I want to get rid of that x to the minus 2, is the claim. So I'll multiply through by x to the power 2, which I can do. And the 1 times x to the power 2 is x to the power 2, minus 2x to the power 4, and then plus x to the power minus 2 times x to the power 2 gives x to the power 0, which is 1, and that times the coefficient of 2 is just 2. Okay, how many...
Flashbacks.
Flashbacks to what?
Algebra 2.
Painful. How many real solutions does this have for x is now the question.
So I have a graph pad on hand. I found my pen cap, but not the pen. This is a problem.
I'm just going to rewrite, while you think, I'm going to rewrite this in a slightly more suggestive way. I'm going to define a new variable y equal to x squared. This will be minus 2y squared plus y plus 2.
I'm doing very bad at factoring.
Well,
okay, I see what you did.
Yeah, you can't factor this. I mean, you should always try to define a new variable so you can just use the quadratic formula. So if we do that, what does the quadratic formula give us for the roots for y?
So this is going to be -1 plus or minus the square root of 1 4 times -2 times 2.
Yeah,
All over -4.
Good. So let's do that thing inside the square root. So it's 1, as you said, minus 4 times 2 times minus 2. So those two minuses cancel, and I get a plus. What's 4 times 2 times plus 2? Well, that's 4 times 4, which is 16, right? I think this is right. 1 plus or minus square root of 17. So we don't actually need to find what these numbers are. We just need to decide how many solutions are we going to get, right? So how many solutions are we going to get to this guy? Well, that are real. So I'm going to get rid of the minus 4, because this is going to be 1/4 plus or minus, well, really minus or plus, I guess I should write, because this plus is divided by a minus, which gives me a minus. This is 1/4 minus plus root 17 over 4. So you should be careful, I think, because it seems like this guy, this thing is going to be bigger than 4, right? So we're going to get one of these roots, which is 1/4 plus something like 4, and one of these, which is something like 1/4 minus something like 4, which will be negative. And these are roots for y. So which of those are going to give us good solutions for x, where this thing has a horizontal tangent line?
I do not see the problem. Oh wait, I see what's going on. Okay.
Yeah, you see the one, for instance, the negative one is going to be 1/4 minus something like 4, so that's a negative number. The negative solution is for y. We're trying to find solutions for x, but y equals x squared. So do we get good roots for x using the negative root from the quadratic in this equation?
No.
No, I don't think so. Good, but we do get ones from the positive root, 1/4 plus this thing. So that thing, I think, gives us a good value for y. And I think that means we should, seems like we're finding 2 points where this guy has a horizontal tangent line. I don't know. Does that seem sensible?
Yeah.
Okay. I think that's actually right. I don't have the answer for this one, so I'm just hoping I'm getting it correct in real time. Let's see if we did everything right. So we wanted this to be 0. We took the derivative. I think this is correct. Derivative of the first. And this times derivative of the second, minus 2x plus this. We expanded this thing out. Plus 2x to the minus 2. Multiplied through by x squared. X squared minus 2x to the 4th plus 2 looks right. I don't see any errors here. Negative b plus or minus. Yeah, alright. I think this is what I would say if I were answering this one. Okay. Alright, this one, I think there's only a couple left. Yeah. So this one I stole from the first exam from MIT's Calc 1. There's two versions of, there's 1801 and 18014, which is the version for math majors. This is the version not for math majors, so it's somewhat less proofy. But anyway, the question is, suppose that you have a function f, and it satisfies this strange equation. It's almost like linearity, except there's extra junk. Linearity would tell you f of x plus y equals f of x plus f of y, but instead we're going to assume that that equation has two extra terms, plus x squared y plus xy squared. So it's a very strange equation for this to satisfy. You add two arguments and you almost get linearity up to this weird pair of extra terms that come from multiplying the arguments. So we assume that's true. F satisfies that for all x and y. And we get an extra assumption. Suppose that the limit as x goes to 0 of f of x over x equals 1. So we get those two assumptions. And then we're asked three things in kind of increasing order of difficulty. What's f of 0? What's the derivative f prime of 0? And then what's the derivative at any point x, f prime of x? So those are our three. Okay, so let's do a first. So what should we do to find the value of the function f of 0 at the point x equals 0?
So I do not believe that we can assume this is continuous.
Yeah, we certainly haven't proven it. If it's continuous, it's not obvious from these two assumptions why it's continuous everywhere. But we know that this thing is true. I don't actually know if this implies continuity, but we know that's true for all x and y. Actually, yeah, it has to imply, well, we haven't proven it, but I actually think this has to imply f is continuous. Yeah, if this is true, I think you can actually prove directly from this that it's continuous. But anyway, that's a side note. Without using continuity, can you see a way to use, actually you can use either of these two assumptions to prove this, but do you see a way to compute f of 0 using either of these two guys?
Could you possibly multiply each side by x of the lower equation?
Yeah, this could work. So you say multiply both sides by x, and then we say limit as x goes to 0 of f of x over x times, you say x equals x. And now we know that if a product of two limits exists, or sorry, if both of the limits exist, then the limit of the product exists. So we have assumed that this limit, the limit as x goes to 0 of f over x, exists. We know that the limit as x goes to 0 of x exists, because it's a polynomial. So indeed, we can actually absorb x into the limit because we've assumed that both of them exist. This is a property we proved about limits of products. So this implies, in fact, that the limit as x goes to 0 of f of x over x times x equals the limit as x goes to 0 of x, which is, of course, 0. So this thing, I see now why you're asking about continuity, because the thing you've just told me is enough to prove that the limit as x goes to 0 of f of x equals 0. So if we have continuity, if we had continuity, then this would mean f of 0 equals 0. So you might reasonably guess that f of 0 must be 0 based on this argument. And actually, if you look at the official solutions, if you go on OCW and look at the solutions to this exam, they make exactly this argument. They say, yeah, since the limit as x goes to 0 of f of x times x equals, or this is 1, it must be true, they claim, that f of 0 equals 0, based on the thing you've just told me. I think that's slightly sketchy, because we don't know that the limit as x goes to 0 of f of x a priori, do we know this is f of 0? There's two ways to get around this question. How do we know it's continuous at 0? One of them is to use the trick that we saw a few slides ago, which is the dummy variable trick. You look at this and say, well, this is the same as the limit as h goes to 0 of f of h plus 0 minus f of 0 over h, and if indeed f of 0 equals 0, then that means that this thing is differentiable. But that's a circular argument. You're saying that this thing is continuous if f of 0 equals 0. So that argument doesn't quite work. A second way to do it, which I think is more satisfactory, is to look at this first equation we're given and say this holds for all real numbers x and y. So if you let x equal 0 and y also equal to 0, then you plug this thing in and you get f of 0 plus 0 equals f of 0 plus f of 0 plus, well, x squared y and xy squared are both 0. So I combine these two things on the right side and I get f of 0 equals 2 times f of 0. Well, that's pretty obvious what the solution is. I subtract f of 0 from both sides, and on the left I get 0, on the right I get f of 0. So, anyway, yeah, this was kind of a rant, but the point of the rant is I don't think the official solutions were totally correct. I think you actually need to put in x equals 0 and y equals 0 in this equation if you really want to know that f of 0 equals 0.
That's beautiful.
It's tricky. Okay, well, good. I think if you were taking an exam and it just said find f of 0 without proof, I think the argument you gave would have been enough to get full credit, so that's fine. Alright, next, what would you do to find the derivative? F prime of 0. I've actually almost given it away in that rant I just gave, but what do you think?
I'll go the way that the textbook wants me to and take the derivative of both sides.
Derivative of...
Get you a circular thing.
Of this equation, you're saying?
Yeah.
Ooh, okay, that's interesting. I didn't think to do it that way. So you take the derivative of both sides of this equation with respect to x?
Right.
Ah, alright, let's try that. So, on the... What did you say?
Something was up and it sounded like super high pitched out of you.
Yeah, I made a high-pitched sound because I was amused with this idea because I haven't thought of this. Okay, so on the left side, yeah, differentiate with respect to x. Y is a constant, so the left side is what? F prime of x plus y times derivative of the inside is 1, right? And then that's supposed to be f prime of x plus 0, derivative of this guy is what, 2xy? The derivative of this guy is y squared, I think. I think I've gotten too excited and now I'm just doing the calculation for you because I didn't think of this. But okay, so suppose I've done this correctly. Now what do we do to find f prime of 0?
Could you... It might not be totally correct, but I my suggestion is put in x equals 0.
Put in x equals 0. Okay, so this gives us x equals 0 means f prime of 0 plus y, so f prime of y. And then you say f prime of 0 plus, well, x equals 0, so this term is 0, and this is plus y squared. So I actually think this is almost the solution to part C, right? Because if you just replace the dummy variable y with x, this tells us f prime of x equals f prime of 0 plus x squared. So that was actually very interesting. What did you say?
Oh, there's our answer for C, I guess.
Yeah, once we figure out, we still have to know what this is, right? This is some number. But yeah, once we know b, we're going to compute that number. Once we know what that number is, you've actually solved C in a way that I didn't think of. So that was pretty amusing. So all right, I'm going to save this for future reference. F prime of x is f prime of 0 plus x squared equals f prime of 0 plus x squared. That was a good idea. Why did you say what the textbook wants you to do when you said differentiating this thing?
I don't know.
Oh, okay.
Just like the thing that a book would want you to do.
I don't know. You're anthropomorphizing your textbooks. Your textbooks have wants and needs.
Oh. Give me a second.
Okay.
Oh, I'm talking me. I don't know.
Oh, I was confused. You were memeing.
Okay,
so that was a good idea. An interesting idea. It didn't apparently give us f prime of 0. So do you have a second idea for finding what f prime of 0 should be?
So I guess we could start with referring to the derivative definition.
Sounds good. So what's that?
So the limit as h goes to 0 of f of h minus f of 0 all over h.
Cool. What can we do with this?
We know that f of 0 equals 0, so that can be gotten rid of. And we can swap out dummy variables and see that this all to 1.
Good, okay. Yeah, so I don't know why I put a box. Yeah, so part B is 1, applying the definition of the derivative, and 2, using the result from A and this assumption. Good, so that's 1. Good, now in the official solutions for C, they actually went through the definition of the difference quotient again and plugged in this thing. But actually we don't need to do that now because, as you suggested, taking the derivative of this equation gives us a very handy result for f prime of x if we know what f prime of 0 is. So actually we already know the answer to this immediately, because if f prime of 0 is 1, then f prime of x for any x is 1 plus x squared. So that was actually very clever.
Or x squared plus 1 if you're basically any math teacher.
Fine. I don't know why addition is commutative. I can write these in whatever order I want.
It looks nice.
Okay.
I don't know why. I actually don't care.
Yeah, I don't care either. Okay, good. That was nice. Other thoughts? Ooh, too much. Other thoughts on this one?
Nope.
Okay, I think I may have actually included more problems than we need to fill the time. Maybe it's just because I wrote down the answer to one of them wrong and that took us longer than expected. Okay, well, we can try this one until you get bored at least. So, this is another problem from the Harvard-MIT math tournament that we discussed before. So, we're given a function f of x minus f of 2x. So this is kind of interesting. There's a function f, and now we're saying this new function, which is obtained from taking f of x minus f of 2x, and we're saying this new function has a derivative equal to 5 when x equals 1, and the derivative is 7 at x equals 2. So I'm just going to, as a hint, write this out for you. So if I take the derivative of this thing, that's, of course, f prime of x by the chain rule minus 2f prime of 2x. So I'm just rewriting the information we're given in the problem statement. This thing equals 5 when x equals 1, and this thing equals 7 when x equals 2. So let me just rewrite that. So this thing equals 5 when x equals 1. What does that mean? So it equals 5 when x equals 1. So 5 equals f prime of 1 minus 2f prime, well, when x equals 1, 2x equals 2. So that's the first bit of given information. And we're told it equals 7 when x equals 2. What does that mean? Well, f prime of 2 minus 2f prime of 2 times 2 is 4 in most countries. So this is the given information. These two equations, the derivative is 5 and 7 at those 2 points. Now here's the problem. You're asked to find the derivative of this other function, which is f of x minus f of 4x, when x equals 1. Okay, so I'll ask you, what should we do to find the derivative of the difference f of x minus f of 4x when x equals 1?
So I do know that we can apply linearity here for reasons that we haven't been told that f is continuous.
Ah, good. Okay, so maybe I should add an assumption. Can we actually prove this? No, I guess we can't. Alright, sorry. I should tell you f is, I don't know, C1. So f is differentiable, therefore it's continuous, and let's assume it's differentiable everywhere. So no worries about smoothness. You can take the derivative wherever you want.
In that case, I believe that we can take the derivative of this equation, the f of x minus f for x equals.
Okay, so what's the derivative of this expression?
Equals f prime of x minus. Let's chain rule thinking. That's going to be f prime of 4x times 4.
Good. So the thing we want to compute is, as you've told me, f prime of x minus 4f prime of 4x. Yeah. 4f prime of 4x. And we want to find what that equals when x equals 1. So I'll write that this way. So f prime of x minus 4f prime of 4x when x equals 1. So when I put in x equals 1, that's just f prime of 1 minus 4 f prime of 4. So that's the thing we want to find. So do you see a way to use the given information, which is written in purple above, to find the expression on the bottom, which you've just read to me? What is this thing in green equal to, if we know this thing?
I guess we could subtract, take our upper equation, we take, we subtract f prime of 1 from each side.
Subtract f prime of 1 from the top equation, you say?
Yes.
So then on the left we have 5 minus f prime of 1, and on the right we have minus 2 f prime of 2.
That got us anywhere.
Yeah, I think we have to combine these two equations in a particular way. So we're trying to find f prime of 1 minus 4f prime of 4. So the thing we want has no f prime of 2 in it, right? So if there's any hope that this is going to succeed, we have to find a way to add these two equations, or maybe multiply one of these equations by something, and then add them together in such a way that no f prime of 2's are left in the result, right? Because the thing we're trying to compute has no f prime of 2's in it whatsoever. So do you see a way to maybe multiply one of these equations by something and then add them in such a way that we get rid of the f prime of 2 factors or terms?
I don't know why, but I'm tempted to say something along the lines of like linearity and an outside multiple affecting the inside somehow. But there's no way that's right. I don't know why I'm thinking that.
Oh, you're saying something like using the coefficients to move inside the derivatives or something?
Yeah, I don't know why.
Yeah, that's not true, so we can't use that. Yeah, this is kind of like in Algebra 2 when you're solving systems of linear equations. Just think of these as variables, right? F prime of 1 is like x, right? So this is like 5 equals x minus 2y, and 7 equals y minus 2z. And we're trying to get an expression that involves just x and z. So we're trying to eliminate the y's, right? We're trying to get rid of these things. So do you see
I guess we could like swap the places to make it more suggestive.
Ah, so you mean write this bottom piece with the f prime of 2 in the second slot?
Yeah.
Yeah, let's do that.
I don't know, it helps.
Good. So that's... I have to find the right color that I used. So 7 equals, well, we want plus f prime of 2 here, and this is supposed to be minus 2 f prime of 4. Okay, so I've swapped the order. Actually, I've lined these up even though these variables aren't the same. F prime of 1 is not the same as f prime of 4. So really, to line it up, there should really be 3 pieces, right? There should be minus 2 f prime of 4, and then this is secretly 0 f prime of 4, right? And this is good. So maybe that's more suggestive. Okay, so what should I multiply the bottom equation by if I'm going to add these equations together and kill off the f prime of 2 factors, or terms, damn it.
We multiply it by 2 to the power of 1.
Good, so double the bottom equation and add the results together. So this times 2. So what does that give us? Now I've run out of space, I guess, but that gives us, well, 2 times 7 is 14, plus 5 is 19. So on the left, 19 equals, this is nothing, 2 f prime of 2 minus 2 f prime of 2 is 0, so that's gone. We still have the f prime of 1 left. This is nothing. And then minus 2 times minus 2 is the minus 4, f prime of 4. Good. So as you've said, we multiply the bottom equation by 2 and add them, and it gives us this equation. But the right side of this equation is exactly what we were asked to compute. We were asked to find the derivative of f of x minus f of 4x at x equals 1, which is precisely f prime of 1 minus 4 f prime of 4. So matching the two equations which are underlined in squiggly, the result for the 3 question marks must be 19. Good. So all we had to do in this problem was 1, differentiate these things and use the chain rule, but then 2, combine 2 linear equations to cancel one factor by multiplying one of them by some number and adding them. and we find 19. Good. Thoughts on that?
It was fun.
Yeah, I think these Harvard MIT math problem questions are always really crunchy and fun to solve for some reason. I don't know. I find this very enjoyable. Okay, I think we're probably pretty close to... Yeah, I don't want to use up a lot of your time since you still probably want to work on the Schwarzian stuff. So maybe I'll just solve the last couple ones for you. So this problem I stole from Spivak. He says, find a formula for the second derivative of the inverse of some function. And why does he say that? Well, we're supposed to have memorized this formula for the first derivative of the inverse of some function, which we derived a few meetings ago. This is 1 over f prime evaluated at f inverse of x. So to find a formula for the second derivative of the inverse, well, hopefully this is now second nature, you want to take the derivative of both sides with respect to x. And when you do that on the left side, you get f inverse double prime of x. On the right side, well, we're going to have to chain rule repeatedly. The outer function is something raised to the power -1, since this thing is in the denominator. And the derivative of, say, x to the power -1 is -1 times the inside function, which is f prime of f inverse of x, all raised to the power -1 minus 1 is -2. So that's the first factor. Then we chain again. Now the outer function is f prime, and the inner function is f inverse. Derivative of the outer function with the the inner function left alone is f double prime of f inverse of x. And now the third chain rule application is the derivative of the inside function. So what's the derivative of f inverse of x? Well, I've already written an equation for that right here. The derivative of the inner function is f inverse prime, which is just this right side here, which I'm now recopying, f prime of f inverse of x. So now I'm just going to combine these. This third factor and this first factor are the same thing raised to different powers. F prime of f inverse of x to the -2 times f prime of f inverse of x to the -1 is f prime of f inverse of x to the -3. So now there's 3 of these downstairs. There's a -1 times this stuff upstairs. So our final result is minus f double prime of f inverse of x all over this junk to the power 3, f prime of f inverse of x cubed. Okay, so that's it's a little tricky, but that's the Spivak problem, differentiating this and chain ruling. Thoughts on this guy?
I have no thoughts.
Okay. I will blaze through the last two. So this is sometimes called the triple product rule. Is this? No, this is out of the AOPS textbook. So you have 3 functions. They're C1, so we can take a derivative. What's the derivative of the product of the 3 of them? F times g times h. So there's a product of 3 functions. This, might seem like it's complicated, but we actually just use the ordinary product rule twice. So I'll write this in Leibniz notation. ddx of, I'm going to write this very suggestively, f times, since multiplication is associative, I just think of f times g times h as the function f times the product of the functions g and h. So the product rule tells us how to take the derivative of a product of 2 functions. So this is the derivative of the first, f prime, times the second 2 left alone, g times h, plus the first function times the derivative of the second function left alone. But the second function happens to be the product of these 2 functions. So now we just apply the product rule again. The first term doesn't change at all. It's f prime gh plus f times Well, the product rule again, the derivative of gh is derivative of g times h left alone plus g left alone times the derivative of h. So now I'll just distribute this guy out, and we see that the answer, the result for the derivative of a product of three functions, is f prime gh plus f g prime h plus f g h prime. That's all. So I like to think of this as, I'll just rewrite it like this to make the analogy more clear. When I look at this, I like to think of the mnemonic as the prime hits each of these three functions successively, right? I think of this as the prime comes down, first it hits the f, so the prime hits the f and it doesn't hit the other two, and then the prime comes down and hits the g, and it doesn't hit the other two, and then the prime comes down and it hits the h, prime lands on the h, and it leaves the other two alone. So I think that mnemonic is very common. When I talk about this with, say, Saab or Chikai, and we're taking a derivative of like 10 functions multiplied together, and we're just speaking informally, we'll say something like, yeah, but when the derivative lands on this guy, you get this, or when the derivative lands on this guy, you get this other thing. So you think of the derivative of a product of functions as kind of this guy landing on each of these functions in turn, and you get one for each of those different landings. But anyway, that's just stupid mnemonic. Okay, questions on this?
I have no questions about this. Though I am curious, do you just sit around a table with Sav and your other buddies, or are you actually in your office communicating with them over Slack or something?
We're usually, well, until Sav had his baby, we were almost always in the office talking about this in either Sav's office or my office, but now we've been increasingly Skyping to talk about this, so, the content of the conversations hasn't changed. We still spend hours talking about just taking derivatives of very long expressions and interpreting the physics, so that part's the same, but before it was sitting around a table in the physics building, and now it's on Skype.
Lovely.
That's the job. Okay, I will solve the last one for you and then leave you alone so you can do work. But this is something I found very frustrating as a high school student. In Algebra 2, you are told this result with no proof whatsoever, and you're just expected to accept it, right? Someone stands in front of you and they tell you, if you have a parabola, y equals ax squared plus bx plus c, and you want to find the vertex of that parabola, which is the point where there's a horizontal tangent line, that this vertex is always supposed to occur at the point negative b over 2a. And this expression, negative b over 2a, is handed down as some God-given right, like this is out of the Bible or something. Why is it negative b out of 2a, over 2a? Who decided upon this? Is this one of the 10 Commandments or something? So let's just prove this. If the parabola is y equals ax squared plus bx plus c, the derivative is y prime of x perhaps, is 2ax plus b, and then the derivative of c is 0, so I won't even write it. And now we just ask, where is it true that the tangent line at the vertex, for instance, the tangent line is horizontal, means that the derivative equals 0, right? Because this horizontal tangent line has slope 0. And then we just solve for the value of x, where this equation is true, that the tangent line has slope 0. Well, this is pretty easy to solve. 2ax equals minus b, or x equals negative b over 2a. Aha! So that's why this God-given expression, negative b over 2a, was handed to you in an Algebra 2 class with no justification. Why no justification? Because in order to understand why this is even true, you have to know calculus, and you know how to take the derivative and use the power rule. So anyway, I just find this very frustrating because I don't like being told things without knowing why they're true. So now you know why this negative b over 2a is true. You just take the derivative and set it to 0, and solve for x to find where the vertex is. But anyway, you've heard enough of me ranting about high school math to fill a lifetime, I am sure.
Not quite.
Okay, good. That's comforting. So I'm probably going to say more shit. But not today, perhaps. Alright. Other thoughts, questions, or remaining business on your mind?
I do not believe I have any further thoughts or questions.
Sweet.
I just realized that your 741 is my 841.
Yes, that's true. I've actually lost track of time. When did we start? Did we go for 2 hours now? Because we were late because of the fire.